Let K be a non-empty subset of Rn, where n is greater than 1. Which of the following statements must be true? If K is compact, then every continuous real-valued function defined on K is bounded. If every continuous real function defined on K is bounded, then K is compact. And if K is compact, then K is connected. Okay, so, sorry, I just got to zoom in here a little bit. So statement 1 is certainly true. A continuous function on a compact subset of R is bounded. Statement 3 is certainly false. I can easily just have K be the disjoint union of two compact sets. Then it's not connected. But number 2, if every continuous real-valued function defined on K is bounded, then K is compact. Well, how do we create a counterexample to that statement? I mean, let's go like this. This is definitely true. 3 is definitely false. 2. I mean, it's tempting to say that this is true, but like if I take I know it says that n is greater than 1, but we could as an example to try and create a counterexample, try to take K to be a one-dimensional, like K take to be a line or something. Or maybe we need to create, maybe a counterexample is creating some kind of like sparse I mean, in terms of the multiple choice answers here, the answer is either A or D. It's a question of whether this statement number 2 is true. So I can't use the multiple choice options to try and back out what the answer is. If K is not compact, then there exists an X in Rn, X in Rn, such that X is not in K, and there exists a sequence, let's call it X sub m, such that xm approaches x. So it means I have some set K, I have a sequence of points which approaches x, but x is not in K. And then I could just let the the function f, f of y is equal to 1 over the distance. So that's continuous. It's real valued. It's defined everywhere on k, not bounded. So I think this is true, which means the answer is D. Simply because, like, you try to create this counterexample. I've given a counterexample to, gosh, what is it? The negation, I don't know all these logical terms. Whatever. Point is, if you give me, if k is not compact, then there exists a function. If k is not compact, then it is not true that all continuous functions are bounded. I guess that is... Every continuous real function on k is bounded, then k is compact. Yeah, k is... Oh my God, my brain is running around itself with the logic here. Okay, these are equivalent, right? And I've proven this. Okay, yeah. So that's my answer, D. Both of these statements are true, 1 and 2. Statement 3 is definitely not true. Very easy counterexample, like I said. Counterexample to statement 3. Take two closed balls that don't intersect. Their union is compact. It's subsets of Rn, right? Just closed and bounded is all we need. It's closed and bounded, but it's not connected. So that's enough. Yeah, all right. Thanks for watching.